Hello everyone, welcome to my YouTube channel Siddhi Singh Aizer Bhopal. So in this video we are going to learn about the how octahedral molecule show its 48 operations. So the topic group theory is application part of stereochemistry, which we majorly learn in organic chemistry. So while learning this chapter we should be very clear about the operations that we learn in stereochemistry, and your imagination should be very good while learning this topic. So stay till the end and let's see. First operation is identity. So while learning identity operation, we could be like, we should rotate it by 360 degree and it will give the same octahedral molecule. So first see, like octahedral molecule is like this. 4 atoms are in a one plane and one atom is in above and one atom is in below. Okay, so the second operation is inversion. So while showing inversion, this molecule will reflect it and this one will reflect it, and simultaneously this will happen. Okay, so this is how octahedral molecules show inversion and identity operations. So the main part of octahedral operations, how it shows C2 operations, and this is literally very difficult to imagine how octahedral is having C2. So there are two type of C2s. There are two type of C2s in octahedral. How there are two type of C2s? So the first type of C2, type 1 C2. So type 1 C2 is like it is passing through the middle of the edges of the octahedral molecule. Like these 4 atoms are in a plane, one atom is in above and one is in below, and one C2 is passing through between these two edges, and one C2 is passing through two edges. Okay, and there are 12 edges in total. Okay, so from two edges one C2 is passing, and then from 12 edges it will be 12 by 2, 6 C2, and we will represent it by C2 dash, because there are two type of C2 and another one I am going to show by C2 only. So the another C2 is passing through these two atoms. So when we pass this C2 and rotate it by 180 degree, it will give the same molecule. Okay, so from two atoms one C2 is passing, and total in 6 atoms. Okay, so it will be 6 by 2. So 3 C2s होंगे यहाँ पे जो अनदर टाइप के होंगे, एंड 6 C2s एक टाइप के होंगे. सो दिस इज हाउ octahedral molecule is having C2s. So in total there are 9 C2s. Okay, so let's have a quick revision of C2 operation. There were two classes of C2. C2 of one type was passing through two opposite edges of the octahedral molecule. So there were total 12 edges. From two edges one C2 was passing. Then from 12 edges, 12 by 2, 6 C2 of the one type will be passing from octahedral molecule. So another class of C2 was passing through two opposite atom of the octahedral molecule. So there were 6 atom in octahedral molecule. From two atoms one C2 is passing. From 6 atoms, 6 by 2, there will be 3 C2 of one type, and in total there are 9 C2 in octahedral molecule. So now we will see how octahedral molecule is having C3 operation. So imagine this is an octahedral molecule. 4 atoms are in one plane, one is above and one is in below. So if we invert it like this, you can clearly see there is a two triangular face. One is like this and another is like this. You can clearly see these two triangular faces are just opposite of each other, and we are going to pass C3 like this. Like this is in 120 degree angle if we will rotate it like this. Okay, so this is how it is going to show C3 operation. Okay. So there are two opposite faces of two triangular opposite faces. So there are 8 faces in total. Okay, so from two faces one C3 is passing. So from 8 faces, 8 by 2, 4 C3 will be passing. So the operations of C3 will be C31, C32 and C33. So C33 is again an identity, we have already considered it. So 4 into C31 and into C32, there will be 8 C3 operations in total in octahedral molecule. So now another operation is C4 operation. So the 4 atoms are in one plane, one is top and one is below. So on holding it from top and bottom and rotating it by 90 degree, it will give the same octahedral molecule. So there are 6 atoms in total from 2 opposite atoms. One C4 is passing. So from 6 atoms, 6 by 2, 3 C4 will be passing. So now there are 4 operations in C4, C41, C42, C43 and C44. C44 is an identity, we have already considered it, and C42 is like having 90 degree and 90 degree 2 times rotation, so it will be 180 degree rotation. So we have already taken this in our account, so we have not considering it. So 3 into C4 1 into C4 3, it will give 6 operations in C4. So now we will see how octahedral molecule will show S4 operations. So the 4 atoms are in one plane, one is in above and one is in below. On holding from top and bottom and rotating it by 90 degree and taking perpendicular reflection of it, it will give S4 operation. Okay, so there are 2 atoms, from 2 atoms, one S4 is passing, and there are 6 atoms in total. So 6 by 2, it will give 3 S4 operation, and S4 operation can be broken as S41, S42, S43 and S44. And S44 is again an identity which I have already considered. And S42 is again S2. How S42 can be like this? So it will be S2, and S2 is an identity, so it will again be neglected. So these two only been considered. So S4, as there are 3 S4 and 3 into 3 S4 1, 3 S4 3. So 3 into 2, there will be totally 6 S4 operations in octahedral molecule. So again for S6, so S6 operation is again like S3 operation. So on passing the axis from the opposite two triangular faces of the octahedral molecule, and this is 120 degree, and rotating it by 90 degree and taking perpendicular reflection like this, so we will get S4 operations of it. So there are total 8 opposite faces, and on totaling and from two opposite faces, one S4 is passing. So 8 by 2, 4 S6 operation will be there. So now S4 can be broken, S6 can be broken as S61, S62, S63, S64 and S65 and S66. So it is again an identity, so we will neglect it. S66 will be it. So before learning about these 6 operations, first see there are 3 formulas. Like S6 can be broken as C6 into sigma H, and there is another thing in sigma S to the power even is again identity, and sigma S to the power odd is sigma H. Okay, another is S2 is an identity. So consider these 3 formulas in your mind. So S6 is like S61, S62, S63, S64 and S65 and S66. So it could be taken as S61 and sigma H1. So it will be S61 only, because it will never give a single elementary operation. Okay, so it will be C62 and sigma H2. So it will be C3, we have already considered it, so we will neglect it. So S63 will be S2, which is identity, so we will neglected. S64 is C64 into sigma H4, which is sigma 64 will be identity, and C64 we have already considered, so we will neglect this operation also. So C66 is identity, this could be also be neglected, and S65 is could be like S65 only. So we will consider these 2 operations of S6 only, C61 and C65. So 4 into 2, there will be 8 S6 operation in total in octahedral. So let's see S4 operation again. So C4 was passing through these 2 opposite atoms on taking perpendicular reflection. it will give the same octahedral molecule. So from 2 atom 1 s4 was passing, from 6 atom 3 s4 will pass. S4 operation can be written as like this. So C42 S42 will be C42 only, and we have already considered it, so we will neglect it. And S44 will be identity, so we will also neglect it. And S41 and S43 will be considering, so there will be 6 S4 operations in octahedral molecule. Same as from opposite two triangular faces, from 2 faces 1 s6 is passing, from 8 faces 8 by 2 4 s6 will pass, and s6 can be written as like this, and we will neglect these operations, these 4 operations, and consider these 2. And why we are considering these 2 operations and neglecting these 4, I have already explained. So this is like the definition of sigma h says it could be perpendicular, it could be perpendicular plane passing through the POS. So this is POS and it will be sigma h. On considering sigma h like this and POS like this will be another sigma h, and that one will be another. So there are 3 sigma h in octahedral molecule. Lastly, we will see sigma d operation. So the definition of sigma d as it is a dihedral plane, so it do pass through by cutting 2 sigma v planes. So it is cutting the edges of the octahedral molecule. So 2 edges, from 2 edges 1 sigma d is passing. So by 12 edges, 12 by 2 6 sigma d is passing. So there are 6 sigma d in octahedral molecule. Okay, so by summing one identity operation, one inversion, one identity operation, and 2 C2s of different types, 6 C2 of one type and 3 C2 of another type, there will be 9 C2 in total, 8 C3 is 8 C3 operation, and 6 C4 operations in total, 6 S4 operations in total, and on totaling them there will be 48 operations in octahedral molecule. So hope you like this video. So stay connected and keep learning and exploring chemistry with me. So for more interesting videos like this, please comment in the comment box. If you want to learn whole group theory like this with imaginations with me, so please comment in the comment box. I will make a complete video lecture of group theory like this.